Can you believe it? There might be life on Venus. Recently, NASA scientists have increased their confidence in the possibility of life existing on Venus by introducing a concept known as the Venus life equation. Once again, we are challenged to journey to Venus and explore the potential origin of life there. When people talk about extraterrestrial life, our minds often leap to Mars or to the icy moons of Jupiter and Saturn. But have you ever considered that our closest planetary neighbor, Venus, might be hiding secrets of life as well? This planet, which appears to be a scorching inferno, could hold mysteries beyond imagination. Recently, scientists proposed a revolutionary idea called the Venus life equation. It even inspired a bold thought: could there be some ancient, unknown connection between life on Earth and Venus? At first glance, this seems hard to believe. Venus is hot enough to melt lead, and the atmospheric pressure is so extreme it could crush a human body in seconds. How could life survive in such conditions? Initially, most scientists dismissed the idea, categorizing Venus as a true hell planet where life was virtually impossible. But everything began to change with the emergence of this new scientific approach, the Venus life equation. The name might remind you of the famous Drake equation, which estimates the number of intelligent civilizations in the universe. Similarly, the Venus life equation was introduced by NASA scientist Dr. Diana Gentry at a conference in 2025, and it immediately caused a stir in the scientific community. The equation is deceptively simple: L equals O, arm C. In this formula, L represents the likelihood of life existing on Venus at any given time. Some might argue that this is still just speculation, but what makes the equation valuable is how the three variables, O, R, and C, break a complex mystery into manageable questions that scientists can begin to study one by one. The first variable, O, stands for origination, referring to the possibility that life might have originated on Venus. How does life begin, after all? One possibility is that life arises spontaneously from non-living matter, a process known as abiogenesis. Another more speculative theory is panspermia, the idea that life may have traveled to Venus via meteorites from elsewhere in the universe. Interestingly, studies suggest that billions of years ago, Venus may have had oceans and a temperate climate similar to early Earth. In such conditions, it is entirely plausible that life could have originated there. The second variable, R, refers to robustness, or how resilient and adaptable life on Venus might have been. Even if life did originate on the planet, could it thrive, multiply, and build a stable biosphere? That would depend on whether there were sufficient energy sources and nutrients to sustain life. The more diverse and adaptable a life form is, the better it can survive changes in its environment. This resilience is key to the development of complex life systems. The third component, C, stands for continuity, perhaps the most critical factor. Even if life began and was resilient, did it survive through Venus's dramatic environmental changes? Today, Venus's surface is incredibly hostile. Temperatures exceed 400 degrees Celsius, and the atmospheric pressure is more than 90 times that of Earth. But scientists have discovered something fascinating. About 50 kilometers above the surface, in the planet's cloud layer, conditions are surprisingly Earth-like. The temperature and pressure at that altitude could potentially support life. Moreover, the presence of water vapor and potential energy sources suggests that tiny organisms might survive there, feeding on microscopic particles floating in the air. Could this atmospheric layer be a hidden Sky Eden, quietly harboring microbial life? By multiplying these three possibilities, origination, robustness, and continuity, we arrive at L, the probability that life exists on Venus today. The Venus life equation doesn't offer definitive proof, but it provides scientists with a roadmap, guiding them toward the key questions that need answering. It shows where to focus their research and which mysteries are most pressing. Venus and Earth are often called planetary twins. They are similar in size, orbit the same star, and both lie within the so-called habitable zone. But while Earth is teeming with life, Venus has become a scorching furnace. What happened? Scientists point to phenomena like runaway greenhouse effects to explain Venus's fate. But let's entertain a more imaginative possibility. What if, millions or even billions of years ago, Venus hosted a highly advanced civilization? Perhaps this civilization was even more technologically sophisticated than our own. Over time, they may have overexploited their planet's resources, triggering an irreversible environmental collapse. Or maybe they were destroyed by devastating internal wars. Perhaps they faced some cosmic-scale catastrophe, like extreme solar activity or an unpredictable galactic event. Whatever the cause, the mystery remains. Could Venus, this seemingly dead world, still harbor traces of life, or the remnants of an ancient civilization? The Venus life equation is not just a formula. It's a beacon calling us to look beyond what we know and explore the unknown with curiosity, wonder, and open minds. Can you believe it? Venus, once seemingly doomed and inhospitable, might still hold secrets of life. In its final moments as a habitable world, could the ancient inhabitants of Venus have poured every last ounce of their civilization's power and wisdom into one grand, tragic mission: to seed the cosmos? Is it possible they launched their genetic legacy, the blueprint of their existence, like sparks of hope into space, toward Earth, which at the time was at a critical stage in the evolution of life? We know that Venus's habitable era may have ended 700 to 800 million years ago, while Earth experienced the famous Cambrian explosion, the dramatic flourishing of complex life, around 540 million years ago. That's a gap of about 1 to 200 million years. Could it be that these seeds of life from Venus reached Earth and, like hidden treasures, lay dormant for eons, adapting, evolving, and waiting? Perhaps they quietly merged with Earth's native life forms, and only much later, when environmental conditions on Earth shifted in just the right way, were these ancient genetic instructions awakened like a sleeping giant. They may have acted as a catalyst, combining with other evolutionary forces to spark the grand explosion of life we see recorded in the fossil record, and possibly even laid the foundation for some of the blueprints of complex life itself. If that were true, then the origin of life on Earth and even the emergence of humanity might be deeply intertwined with a mysterious and long-lost neighbor that once shined brightly in our solar system: Venus. Of course, this is purely my own science fiction speculation based on a number of intriguing scientific mysteries, but scientists have indeed suggested that Venus may once have been quite pleasant. There might have been oceans, continents, perhaps even tectonic activity, much like early Earth. This habitable period could have lasted for billions of years, but somehow things went terribly wrong. A runaway greenhouse effect caused all the water to evaporate, and thick layers of carbon dioxide trapped immense heat, sending Venus down a dark path of irreversible transformation. But here's the twist. While the surface of Venus is now completely hostile, the planet's cloud layers, about 50 kilometers above the surface, are surprisingly Earth-like in terms of temperature and pressure. On Earth, even at such high altitudes, microbes can survive, and scientists have detected strange chemical signals in the clouds of Venus, things like ammonia and unidentified substances that absorb ultraviolet light. Could these be the faint traces of life? This is where the R and C in the Venus life equation become crucial. They help assess whether such cloud-based life is scientifically plausible. And make no mistake, the Venus life equation isn't just about understanding Venus. It could also revolutionize our search for life throughout the universe. Think about it. Earth and Venus started with such similar conditions, yet one became a thriving paradise and the other a furnace. Understanding why they diverged is essential for determining whether distant exoplanets are truly habitable. With current telescopes, we can measure the size, mass, and orbital distance of exoplanets, but we know very little about their actual conditions, whether they have atmospheres or whether those atmospheres can support life. The Venus life equation offers a new way of thinking, a framework that could help us better identify which exoplanets are worth exploring. More importantly, it reminds us that a planet's habitability can change. Venus might have been habitable for billions of years before its collapse. So, how many other planets out there might have followed the same tragic path? How many former Earths have now become Venus 2.0s? If life is truly found in Venus's clouds, it would upend everything. It would mean we can no longer just look at a planet's surface. We'd also need to study its atmosphere. Our definition of a habitable planet would have to be rewritten. That's why NASA is preparing missions like Da Vinci Plus and Veritas. Da Vinci Plus will dive into Venus's atmosphere, sampling the gases and sniffing out their composition, while Veritas will capture high-resolution imagery of Venus's surface. The data these missions return will help us refine the OR-C components of the Venus life equation and bring us closer to understanding the planet's mysterious past. Isn't it amazing to think that while we've been gazing at the stars in search of alien life, the most astonishing discovery might be waiting in the clouds of our nearest neighbor, Venus? Maybe the universe is hiding a grand surprise for us right there, closer than we ever imagined. So never underestimate the power of possibility. Keep exploring. The answers we seek might be waiting in the most unexpected places. Isn't that right?